let's talk about the stuff I wanted you to take a look at from yesterday.
I went down there today.
I am on page 125. Page 125.
It's all good, Ryan. I know
Yeah,
where to go.
DTC.
Don't worry about it. TTC knows what it is. TTC will.
All right. So my plan for this week, I won't be here tomorrow, and Wednesday, Thursday, or Friday. Wednesday, Thursday, there will be just kind of a video that will go over the assignment and then the lecture. Friday, I actually have a quiz as a group on Schoology. You gotta trust me, I haven't misled you yet, have I?
No,
I think you'll like this quiz.
you got us. I trust you.
There's actually 5 different movie trailers that you have to watch that are linked to it.
Oh shit.
They're my top 5 favorite movies, but it goes along with the questions. But you get to watch the trailers of my favorite movies, stuff like that. So,
Alright, hang them on the wall.
maybe
What movies?
you'll have to see on Friday. So, yeah, it's kind of fun. But we're on page 125, so let's make sure I teach this and we do all right. Fast food restaurant offers 3 kinds of hamburgers: hamburger, cheeseburger, bacon cheeseburger. Am I the right thing?
You are.
Okay.
Right.
Okay. Half the sales on the hamburger sales, 1/4 cheeseburger, 1/4 bacon cheeseburgers. Has the sales distribution changed recently? Okay, so you have hamburger, cheeseburger, and then bacon cheeseburger. And they are claiming that,
Or how about the heart attack burger? This hamburger with bacon on it.
Oh, what the hell?
so they're claiming all the sales have been this over the years. We want to see if it's changing. So our null and our alternative.
Where's that at?
So burgers are equal to ratios or something like that. And then burgers are not equal to ratios. I don't know. I'm just making up a null and alternative. I don't know if that's how I'd really state it, but it seems good to me. Make a chart showing the observed and the expected values for that. Okay, so this is the observed, or wait, this is the expected, excuse me. We have to figure out our observed. So fast food offer 3 kinds of hamburgers: hamburger, cheeseburger, bacon cheeseburger. Historically, half the burger sales were hamburger sales, 1/4 cheeseburgers, 1/4 were bacon cheeseburger. Has they changed? Oh, and then they said a random sample of 160 sales shows 102 hamburgers, 34 cheeseburgers, and 24 bacon cheeseburgers. So if we were to do this, if half our sales had been that means this should have been 80. Because half of 160 is 80, and then 1/4 of that is 40, and then 40. So that our expected values of our sales should have been 80, 40, 40 if we were going along with the half, 1/4, 1/4. We have to observe 160 sales, in which we had 102, 34, and 24 that had taken place. So that's all you have to do with that problem so far. Okay, we will start getting into the chi-squared. There is a link that's on Schoology. Once we have to figure out the chi-squared, that will take you to a preloaded Desmos to help you, because Desmos won't do the chi-squared as it sits. It goes a little different. All right, so that's problems 1 and 2. Problem number 1, problem number 2. Bless you. Bless you. Are the 12 zodiac signs equally distributed among the population? A random sample of 240 people is conducted. So, our null and our alternative.
Zodiac is equal to distribution.
Zodiac equals distribution, yeah. Zodiac is not equal to distribution. Okay? And I know there's now a 13th one, and people are like, oh, yay. All right, so they claim, what would the expected value for each of the 12 zodiac signs based on your random sample 240? Okay, so if we had 240 people, we'd have all 12 zodiac signs, 4, 5, 6, 7, 12, and I'm not going to go and try and figure that out. We would expect 20 of each, right? 20 divided by 12? 24 divided by 12? Is it 20? Am I right? Hey! 240 divided by 12. Oh my gosh. It's 20, right? Yeah, so it should be 20 all the way down. And then, that's all you have to do on that problem. That was pretty simple. And then sale of Starbucks gift cards for the past 10 years has been stable. Broken down as follows. So denominations of 10, 20, 30, and $50 accounted for 52, 30, and 10 and 8% of the sales. A large new Starbucks ad campaign is conducted to increase sales of the larger denominations. A random sample of 1,000 gift cards is obtained. The breakdown is as followed. So we have that. All right, so our null for on page 126. Our null and our alternative. Gift cards, GC is equal to the percents, and gift cards are not equal to the percents that were given. Okay. Create a chart showing. Okay. So we have the $10, the $20, the $30, and the $50. I'm sure there's others. And these are the percents. So 52% here, 30% here, 10% here, 8% here. And then they did an observation where you had 460 here. This was out of 1,000 sample. 460, 280, 180, and 80. So if you go and figure this out, this would be 520 would be what's expected. This would be 300. This would be 100, and this would be 80. Okay. Create a chart following. And then for problem number 7, it says which denomination was observed and expected the same thing. Well, the 50s were the same. So that did change. So would this suggest anything about the effectiveness of the campaign? Being they were trying to get more people to spend more money on the bigger denomination one. Looking at that, it might not be good, but you can't just make a conclusion based on a coincidence of a random sample of 1,000. All right, so that's chi-squared. Let's go to page 50. All right. So chi-squared deals with oh my gosh, if I could spell, this would be amazing. Chi-square, you deal with observed values and you deal with expected values.
There's no way.
There's no way.
And then the chi-squared, if you see like this x squared, this is the chi-square. And it deals with the observed minus the expected quantity squared, all divided by the expected. Okay? So if we go back, hey, you can see it. We're on page 50. Cool. If we go back to the cards that we were dealing with the other day, where you were hoping you get 8 baseball cards of each, and it turns out that it wasn't, then we can start dealing with chi-squared on this. And am I okay? We're good. All right, so let's go back to our chi-squared situation. We had baseball cards A, B, C, D, E. And we had observed where we had 11, 7, because remember we went and bought 40 boxes of this cereal to try and get the baseball cards. We were expecting to have 8 of each. Alright. So, if we wanted to figure out the chi-squared, what we're going to do is the chi-squared will be the observed minus the expected squared over the expected. So this is going to be 11 minus 8 quantity squared over 8. This one would be 7 minus 8 quantity squared over 8. This one would be 6 minus 8 quantity squared over 8. This would be 9 minus 8 quantity squared over 8. And this would be 7 minus 8 quantity squared over 8. And if we went and figured this out, this becomes, guys, I'm recording on that computer. Thanks. 11 minus 8 is 3, 3 squared is 9, 9 divided by 8 would come out to 1.125. 1 minus 8, or 7 minus 8 is negative 1, negative 1 squared is 1, 1 squared, 1 divided by 8 is 0.125. 6 minus 8 is 2, 2 squared is 4, 4 divided by 8 is 0.50. 9 minus 8 is 1, 1 squared is 1, 1 over 8 is 0.125. And then 7 minus 8 is 1, negative 1 squared is 1, 1 divided by 8 is 0.125. And then we add these up. If we add all these up, it comes out to 2.00. All right. So, how this chi-squared is going to work is this on Desmos. We have a sample. We have 5 different things. Okay? We have a chi-squared equal to 2.0. Okay? I just want to show you how this works on the Desmos. So if I go to courses, business or stat analysis, down this week, and I click on this for chi-squared distribution on Desmos. I was hoping it would do that. All right, so degrees of freedom. I have 5 things. So my degrees of freedom would be 4. And then as I move down this, I have an R value that came out to 2.0. So it's just a sliding scale. Oops. Stop. All right, so that gives me an S value of 0.74. And that'll actually go along into tomorrow's lesson. But that 0.74 becomes your p-value. That p-value in this case is bigger than 0.05. So you failed to reject your null because you didn't find evidence against it. So in this particular thing, because we came up with this, it was purely coincidental that we came up with our observed count was different than our expected count. And that's how the chi-squared is. So that's linked on Schoology, so that'll be helpful for you. You guys want to see, this is crazy, and I praise people who are math nerds. Okay, so the graph, this is the equation to generate the graph. And they had the limits. And then the calculations. So this right here is calculus, it's an integral. And then your degrees of freedom, oh my gosh, it's crazy. And it has all the rounding stuff in there too. It gets to be so Dr. Ali Everett figured this out, how to make it work on Desmos, which I think is pretty cool. But that's what we have. So what we will do is come tomorrow when we're in class, or you're somewhere in the vicinity of school, or you're sitting at home saying, dude, Stirrup's not there, I'm not going. I would truly hope you watch the video that is available for you, because I'm not going to go back and teach it. So if you would, take a good solid look at page 127, 128. I will go over 127, 128 with you in the video tomorrow, as well as teach 7.3. Then on Thursday, what I'll do is I will go over 7.3 and then I will walk through, going through just 7.1 to 7.3 review. And then you have a quiz as a group on Friday. It's 5 questions. Trust me, I haven't misled you. I think you're gonna enjoy the quiz. You're gonna be like, dude, I hope all the rest of our quizzes are done this way because that was fun. But of the 5 questions, 3 of them kind of sort of have to do with this. The other 2 questions list, they have the video links to my top 5 favorite movies. And then what do you know about me? See if you can figure out the order of my top 5 favorite movies in order that are listed. So you have to link them in order. And then the last one is just kind of an opinion question. So don't worry, the quiz on Friday won't be hard. Hey, let's face it, you gotta watch some YouTube videos of Star's top 5 favorite movies, which is kind of fun. My expectation is before you end the school year, you watch at least 3 of those movies, if not all 5.
Which movies are they?
You'll find out come Friday.
If you've already seen them.